Greg Orloff with IIoT World, and I'm here today with Mims Talton. Mims is the CEO of Flogistix, and they're a technology company in the oil and gas sector that specializes in helping organizations reduce carbon emissions and also optimize process efficiencies and revenue. If we peel back that onion a little bit, Flogistix leverages an engineered approach to help customers with their vapor recovery, compression, and water transfer needs to ultimately optimize their well operations. So Mims, welcome. Thanks for joining us today.
Thank you, Greg. Glad to be here.
Glad to have you. So if you could maybe just give us a little bit, maybe a couple other layers of the onion back and tell us a bit about Flogistix.
Yeah, so we basically have three distinct businesses. We have atmospheric solutions, which includes our vapor recovery systems, whereby we're basically placing machinery at the point of production of capping emissions, which is predominantly methane emissions in our case. So, in fact, we think that we're collecting about 8% of the total estimated emissions onshore U.S. In the industry. So, pretty sizable number, and one that we can now track now that we've gotten big enough, and so that's exciting. The second business we have is really our production optimization business, where we use our compression and our technology to increase the amount of oil and gas that the producer can pull out of the ground, basically. So we're increasing volume, and of course, cash flow and proven reserves behind those units. And then lastly, our third business area is what we've been referring to as Flogistix Digital, which is all of our cloud data and to deliver these services. We build most of it for ourselves, although lately we have been specializing in contracting some development, like we've done with Ursula Leo on the digital twin project. But really, Flogistix, we've got, I don't know, we're probably around 250 people or so, and we operate, I think we have about 13 districts currently, and that's basically all the shale producing areas in the domestic U.S. And as I mentioned, we are celebrating our 10th year, so excited.
Well, hey, happy anniversary then. That's wonderful to hear.
Yeah.
Companies, you make the mark of a decade, that's an impressive feat, so congratulations to you and the team.
Well, in our industry, it feels particularly symbolic, I guess.
Indeed. So tell me a little bit about I guess the digital side of your operations, because I think when myself and others, maybe you think about the oil patch or the oil and gas sector as a whole, you don't necessarily think cutting edge and bleeding edge industrial IoT. So tell us some of the things that you guys are working on and doing out there now.
Well, the Flogistix business model is a little bit unique in that we're spread out. So we cover a tremendous, basically the United States, the huge section of the United States anyhow. And so all of our equipment, our individual compressors are located at the site where the oil and gas produced. And so we're kind of spread out. And so in our case, remote operations take on a particular definition for us because, we don't want to have to go out to every site, reoccurring for repetitive problems. Obviously, we can't make any money doing that. So efforts on areas to improve our remote operations. And so our ability to manage our fleet, we own about 2,500 compressors. And as I mentioned, they're spread out. So just having them all in one place electronically is a huge thing. But then, of course, each individual unit is speaking to the cloud once a minute, and we're pulling down about 56 data points per machine per minute. So we've got a tremendous amount of data. I can't even remember anecdotally how much that is, but a lot. And then, of course, once we have all that data in the cloud, we do a variety of things to optimize the machinery with those data streams.
You've got a lot going on then in terms of predictive analytics, I would assume then, or preventive maintenance type of tactics.
Absolutely.
Just from a ballpark then, what is it? There's got to be a cost savings if you can prevent that. What does a typical run out to a site cost? From if it's not money, resource.
Yeah. So when you're honest with yourself about a fully loaded cost, in a business like ours. You've got trucks and fuel and insurance and salary and you know, the employee taxes and all the stuff. On a fully loaded basis, we figured that it costs us about $450 to drive out to one of our sites and literally just get out of the truck. That's before we do anything. So our costs, you know, is significant. If you figure $450 per site visit, well, in the last 2 years, we've been able to reduce our site visits an average of 10 times per unit per year. So it's a phenomenal number. I mean, if you run that out times 2,500 units,
Well, that's a big
you know,
savings.
across the year and reducing it 10 times, it's a big number and it adds up quick. And so, and you know, besides our own operating costs that we're trying to reduce or to manage, what we really get out of all this technology is the ability to apply these compressors in ways that to date they hadn't been able to be applied in this particular fashion because of the real-time data feeds that we get off of it. We've got self-optimizing compressors in the field. So for instance, our gas lift compressor package is designed to inject gas into the well in order to lift the oil out of the well. And in doing that, there is a sweet spot in terms of the daily volume of gas that we inject. And that changes all the time based on bottom hole conditions, and the system
makes
is
sense.
smart enough to look at all of that. Yeah, and to calculate the optimal injection rate all the time. You know, whereas it would take a petroleum engineer several days to do this long calculation, we're doing it on the spot quickly so that the injection rate can be modified and optimize the oil production. That's all. Yeah,
Wow.
and that's all a function of the data that we get off of the application. So I mentioned downhole conditions. So ideally, we actually monitor a real-time bottom hole pressure sensor in the well, but those aren't always available. So we have to use engineering calculations to calculate the bottom hole pressure.
Got it. So then maybe walk me down the evolution and the path of the digital twin, or the appeal of it, and maybe talk a little bit about the partnership you see with Ursa Leo.
Yeah, so let's see. We got kind of intrigued with this idea about a year and a half ago, and I'm trying to remember what got the whole thing started, and that's escaping me. But the long and short of it is that I've had this idea that I wanted to be able to operate virtually. And somehow or another, John and I got introduced. Actually, it was a mutual friend from MIT that introduced us. And John just happened to be, you know, in the right place at the right time for both of us, you know, and we started talking and very quickly I figured out that John and his vision was a vision that I needed to ride in order to accomplish my ultimate goals. And so we set down the path of scoping out the work required to deliver this system. And we think we've got about 10 months worth of really focused development, software development, before we'll be able to deploy and begin to realize the benefit. So
it's a journey. Yeah, it sounds like it's a journey.
It's a journey. It's a journey. I mean, it's a journey, but ultimately, I think we'll be able to operate virtually, and I think we'll be able to improve the performance of our machinery and cut costs at the same time. So it's just a natural evolution of our platform, if you will, and how we deliver service to our clients. I think that the digital twin environment is going to be fantastic for training. It's a cloud environment where we can have students and an instructor, and of course our machinery is in the foreground so that we can look at individual parts. We can take the machine apart, put it back together, simulate events in the field so that the technician can react. I mean, just really the sky's the limit on the training side of it. So we're actually going to focus on the training component first because we think there's such good low-hanging fruit for us to pick, so to speak, on the training part of it.
So maybe switch gears a little bit and touch on some of the newer, I guess, intricacies of doing oil and gas. I mean, sustainability has become a massive. I don't want to use the word hurdle because I mean it's a necessary component. I mean, when you look at that and you say, how do you reduce carbon emissions? I mean, can you talk to me a little bit about the opportunities there, if you could, maybe with some of the other technology advances you folks are doing to minimize that type of release?
Well, of course, with the emergence of ESG and you now have, I've lost count, but multiple trillions of dollars worth of investment bankers that won't fund a deal without the proper ESG in place. And the same thing applies to oil and gas. And so in some ways, oil and gas is sort of trying to catch up to the ESG trend a little bit. But the data that we generate off our machinery is directly related to the carbons that's captured and kept from being vented or flared to the atmosphere. And we're talking about methane specifically. And methane, because of its heat trapping ability, they say is 86 times more harmful than traditional greenhouse gas contained and utilized. I mean, besides the environmental impact of venting and flaring, you have the economic impact, and oil and gas companies are all about economics right now. Everybody's trying to survive, and so this gas is very high BTU, and so it gets a good premium price in the market. These vapors that we capture. So we're currently capturing about 400 million cubic feet a day. And that, as I mentioned, the BTU content is very high in this gas. So it's the equivalent of, something like, I don't know, 700 million cubic feet a day on an energy content basis.
That's a significant indeed then.
Yeah.
So it sounds like you folks are doing well in spite of the challenges that have been thrown at us. I mean, I think the current pandemic or the COVID situation has definitely impacted a lot of businesses. Anything that's significant there from your perspective?
Well, we've of course had to close our offices. We did just go back to the offices a couple of weeks ago, working full time. And that's going okay. But we really during the heat of the pandemic, the technology that we have available to us, we can fall back on that, and we operate remote anyhow. So from all aspects of our business, from our enterprise software system that we wrote and developed, to our Flux telemetry network, that is our own system. That's really the platform that our customers will access the digital twins going forward.
Got it. So it sounds like you've taken it in stride and you're managing your way through it. Is there anything keeping you up at night, working in the back of the mind as the CEO of the organization?
Yeah, absolutely. This is not a regular cycle in oil and gas, if you will. I mean, what we've seen happen with the pandemic is it's accelerated underlying trends. I think we've all recognized that in our personal lives, that the pandemic has tended to accelerate these things that were already going on. And one of those things, of course, is the energy transition. Which we are deep into currently. I mean, the idea that that the energy transition is sometime in the future.
It's now, right?
True. We've been transitioning it now, and it's been, as I said, it seems to have been accelerated in terms of people's expectations out of the oil business in general, related to ESG matters, and oil's got a wonderful, oil and natural gas both have crucial roles to play for the populations around the world, but oil has to compete against other fuels. And what I mean by that is our pollution at the point of production has to be eliminated. And that's our mission at Flogistix, is we aim to eliminate emissions at the point of production of oil and gas.
Really, so minimize it at the source. Got it. It makes a lot of sense. Mims, another question for you. I know we see a tremendous amount of uptake in drone technology, and where drones are being utilized in different capacities where they've never been leveraged before. Tell me a little bit about you folks. Are you engaging in the drone model at all for any of the work that you're doing?
Yes, it's actually an exciting field. Most people don't realize it, but natural gas is odorless and invisible to the naked eye. And so natural gas leaks are kind of elusive, and emissions and ESG reports and safety of our workers. And it's just not something that we can, in economics, you can't sell a product that's escaping to the atmosphere. So what we have done is we've taken our expertise in detecting methane using flare cameras, handheld cameras, and we've adapted that to actually 3 different methods for detecting methane gas or natural gas mounted on drones. So we have 3 methods. We have a sniffer method where the instrument actually has to intersect a cloud of the methane, and then you can map it. And then we have a laser method where we can actually identify methane at 300 feet, and it will give us a parts, and it will actually give us a parts per million reading. And then we have OGI camera manufactured by Flare that gives you a really nice image of the methane from the leak source. And so you kind of use those 3 different methods depending on the circumstances of your location to identify all the leaks, and of course repair them and keep everything really tight and clean.
Wow, so that's got to open up a lot of literally a lot of space in terms of coverage if you're able to access that with a drone. Would they traditionally somebody do that by foot before, or would it be like manual inspection?
Yeah, they would be manual handheld inspections, and with the drone application, we think we can cover, a factor of 10x. And it's probably going to be higher than that once we really get going. But we feel like at a minimum, we can cover about 10 times more ground in a day using a drone than a guy on foot. The drones, of course, is you have, besides the laser and methane sensors that we're using, you of course have thermal imaging cameras and all kind of cameras, but in particular thermal imaging. And that has some unique applications for us in oil and gas as well. And I think that the ability to make 3D models of things out in the field somehow or another is going to connect with our digital twin project in the future. I'm not sure how or when, but I do feel like there's going to be a connection between our drone activities and our digital twin work at some point in time.
That'll be interesting to watch that evolution. Yeah. Indeed.
Yeah. Yeah. So kind of exciting.
No, very exciting. Thank you. Well, Mims, I appreciate you taking the time to talk to us today. Best of luck to you folks in the balance of 2020 and 2021, and I'll be anxious to hear how the relationship unfolds and how you guys leverage the digital twin.
Thank you, Greg. It was a pleasure.